X, yeah? X. Oh! No, we can skip Mensa. Mensa's boring. Let's go to human pregnancy. There we go. We'll just use the whole board. Come on now. Now, these numbers are not perfect. Depending on who you talk to, they vary slightly. What I've used here is I've used the ones that I see the most often. And the ones I see the most often is human pregnancy averages 266 days and has a standard deviation of 16. That's what I see. I see that the most often. Of course, the conversational unit that we always use for human pregnancy is what? 40 weeks, good. I was going to say 9 months. I hear 9 months very often, but 40 weeks is another one, yeah? Which is 40 weeks is the latest. Let's get back into that in a minute. Yes. I want to examine the extremes of pregnancy. First, I want to examine the ones that are too short. The preemie births. The preemie births. Now, again, there is no one universal definition for a preemie birth. No one universal definition, but one that I hear quite a bit is it's the shortest 5%. Some people have been told if they're shorter than, I think it's 37 weeks, it's preemie, or 36, which is, I mean, that's a month off of a term. That's excessive. But this is one I see quite often. The shortest 5%. The shortest 5%. What triggers that? What then, if we accept that as a definition for a preemie birth, what day is that, right? Because the thing is, it's telling us it's the shortest 5%. But what day triggers that? Like, how long would it actually have to be in the shortest 5%? What is the 5th percentile for births? So let's answer the question kind of together. Votes? Guesses? No, it's Thursday week now. You're done guessing. 34? Oh, 234. 234 for, no, not two. Okay, 234, 234 days. I like that. So here's...
It's the lowest 5%?
The lowest 5%. Here's the bell curve for pregnancy. What's in the middle?
266.
Good, 266. We know the standard deviation 16. I say we know this. These are the data that are given to me that I can harbor on, that I can harvest. So 16 days either direction. We add, subtract 16.
250.
That's going to get us to 250 down here. Yep.
And 282.
And 282 up here. If we go out 16 more, we're at 298, I think.
Yes.
And then 234. Oh, there's 234. Good. That's where I got a 234 from. Love it. Now the 234, this is where it gets interesting. The 234, if I draw a little line here and shade that way, how much area did I pick up?
2.5.
That's the same 2.5% we got with the Mensa IQ scores, or the superior IQ scores. Same as if we went 298 and above. That's still outside of 2 standard deviations on one side. So it's 2.5 down here, and it's 2.5 down here. So clearly, what we need is not 234, which corresponds to a z-score of -2, but something just right of it, don't we? We need something that picks up a little more area. This picks up too little area. This is the extreme, this is the extreme preemies, if you will. 2.5%. We need a little bit this way to pick up a little more area. The question is where? What does it? Now we need precision. We can ballpark it, right? We can say, 1.5. We can ballpark it all you want. That's totally fine. I got no problem with you doing that, as long as you're just having a conversation with somebody. But if you're trying to base medicine and science on this, you probably want to have a better than a ballpark. So I'm going to put a little boop with a question mark right here. But all we know is that that area, good Lord, is 5%. I'm having a high gravity day today, I apologize. So the question now is, if we know that cuts 5%, what's the z-score? What the hell? Where'd that come from, Jolene?
Normal.
It's the normal? What are you doing over there? What did you went this to normal, what did you do? Turned it on, ran the program.
I did,
Back up, very beginning.
we're working backwards.
Wait, stop! Wait, damn it. She said it's a backwards problem. Why is it a backwards problem?
We have a percent.
Because you have the percentage and you don't have the score that makes it. Thank you. Now, the best part about this, the best part of a backwards problem versus a forwards problem, is it is literally backwards. Everything is backwards. Think about the process we did with the IQ questions over there. We started with the raw scores, we then converted them to z-scores, and then the z-scores became an area. So I'm going to put that over here, a little aside. So with a forwards problem, you start with a raw score, then you go to a z-score, and then you find the percentage or the area. That's the forwards protocol. We did it twice or 3 times already. Beautiful. A backwards problem is exactly the opposite. A backwards problem is exactly the opposite. Backwards. You start with where the forward stops, which is with the percentage. You then go backwards, get the z, and then you end up with the raw score, which is what you want. You want to have the raw score. You want to be able to say, it's this many days. It's this many days for the at max for the preemie birth to exist. Good. So whereas this one we have to start with a conversion to get from raw to z, here we're going to have to finish with a conversion to get from z to raw. Yes, everything's backwards. I love it. Here's just the normal step at the end here. So we have to use, as Jolene just pointed out, this is the normal step in the beginning here to get from percentage to z. Let's grab it and see what we're talking about. See what we're talking about. Swing it over here. Jolene. Excellent work, my friend.
Yeah.
Seriously, right? That was yeah for something else. Sorry. Oh, you give props. More probabilities, yes! Definitely backwards. Got the area, going for a z. Which way is the area going to shade? Now, I'm exactly going to shade left. Yeah, because I'm giving you, it's a percentile ranking, which is always going to shade left. I've given you this tool to take you past 243 if you need it, okay? So you can also shade to the right sometimes if you want to shade to the right sometimes, which would be if you want to see the ones that are going too long. But this one shades definitely to the left. What's the percent as a decimal? 0.05. Be careful with that. Don't put it in 0.5, otherwise they're going to tell you average is premature. Here it comes. There's your area. It should look familiar. It's the same area as before, or similar area as before. There's the negative 1.64. That was Michael Phelps' z-score in the, oh, that was his 200-meter butterfly z-score, I think.
Yeah, we're backwards.
So he's premature. His 200-meter butterfly is wonderful. That's wonderful. Negative 1.64. Swing this back over. And that's as far as the normal can take you. It can't take you anywhere else but that. It stops. The normal lives on the z bell curve, 1.64. So you could go to an expectant mother and say, yes, if you have a pregnancy that is 1.64 standard deviations below average, we're going to have to put your little baby, you have to be premature. We have to then take other measures. The mother's going to say, this is hard enough without that crap. Tell me a day. Tell me a day. Good. Tell her a day.
240.
What the hell? Where did 240, Jolene?
I plugged it back into the equation that we...
Boom. Remember what we talked about with a forwards problem. We went from raw through a conversion to get to z, and then z through the normal to get to the percentage. Remember that?
Yeah.
We have to go exactly backwards. We just used the normal to get from the percentage back to z, and now we have to go through the conversion to get the raw score. Exactly. So you've got this beautiful conversion formula, x minus mu. We've got z equals x minus mu over sigma, which is a beautiful conversion. This is a beautiful conversion fact. Love it. Now, actually, can I do a teeny bit of algebra on that, if that's okay with you guys? Because, I mean, I see that that's negative 1.64. We just figured that out, right?
Yeah.
We know that's 16. That's 16. That's 266. We got to solve for x. Can I solve for x right now? And then just plug everything. Let me see if I multiply z sigma plus mu equals x. There we go. Let's use that one. It's easier. Because then it's just 16 times negative 1.64 plus 266. And then out comes the number of days. So you're going to have negative 1.64 times 16 plus 266. And that's going to be That's like 20, that was your 240 you got, right?
239.76.
Ish.
Ish.
We're gonna call it about 240. And now there actually is a unit on it, days. That has a unit. This doesn't, but that is days. And that is days. You're adding days to get days.
Where's the 16 from again?
Ah, given, has to be given. Thank you, Patty. Has to be given.
Oh.
You have to have two parameters given to you with a bell curve problem. One is the average, one is the standard deviation. This is why on your exam I make you go find them, because I'm a bastard. I make you go find them off a pediatrician's growth chart to figure out what mu and what sigma are. But you have to know those, because the mu tells you where the curve is left to right, and the sigma tells you how tight or how relaxed the curve is. 16 is pretty wide. I mean, it's like the IQ curve for that matter. 15 is pretty wide. Is that fair?
Yeah.
You butt? Okay. Maybe. Ish. So, you could say that if a pregnancy lasts fewer than 240 days, it's defined as preemie. I actually almost got in a fist with a midwife once about this. I had a midwife in class. Love midwives. I love them. We used one when Jen was pregnant. It's phenomenal. And she's like, that's wrong! I'm like, I didn't say it was right. I said that's what I found. This is the data I found. She's like, but you're wrong! Like, I love you. Please put the knife down. I'm saying based on the data I have, and based on the definition of preemie, that's what premature is. Hopefully you can see that. I mean, it's a little tiny bit of black and white and a roll of gray. If you've defined premature as the 5th percentile, and you've defined the human length of pregnancy as 266 plus or minus 16, then that's correct. Hey, you can also figure out what the 95th percentile is, can't you? You can also figure out what the 95th percentile is. If this is the 5th percentile, 240 days, right? So this is 240 right here. That's 26 days down from 266. If you go 26 up from 266, that has to be the longest 5% cutoff, doesn't it? Does that make sense? See what I'm doing right there? Just using some symmetry. If 26 down puts 5% in this tail, 26 up has to put 5% in this tail. That'd be the 95th percentile. What do you think that's called? Overdue. Get the baby out! No, actually, that's what you technically would induce, except I have never ever seen anybody use that measure for induction. I started thinking about this quite a bit when Jen was pregnant. I'm going to start the camera and stop it again, or stop it and start it again. Is everybody okay with the preemie birth and how we got the... Okay, good.